All right. Hey, pre-calculus, we're looking at question 27 now, okay? Question 27. I got some water. We're going to keep going here. All right. So it says evaluate the function for f of -2 using the graph below. So in plain English, that means, hey, what's going on when, what's going on when x equals -2? That's the question you're being asked. And we need to look at our function here. Okay, so I see my function, and I'm trying to figure out what is going on when x equals -2. And when x equals -2, I have a y value of -3. So that's our final answer. So you might have to zoom in, but when x equals -2, we have a y value of -3. That's our answer. All right, let's move on to question 28. It says solve for x. All right, so my first thing I'm going to do here, I've got 66 equals 5 times -6 plus 8x minus 8x. All right. So our first step, I see some parentheses, so PEMDAS, order of operations. Always distribute first. And so let's rewrite our second line after we've multiplied out by 5. All right, cool. So I'm left with 66 equals -30 plus 40x minus 8x. Now we can combine like terms. In that case, that's 40x minus 8x. All right. And from here, we can solve. So I'll start by adding 30 to both sides, then dividing. So I've added 30 to both sides. I'm left with 96 equals 32x. And my final step here, I was going to go ahead and divide both sides by 32. So my final answer is x equals 3. That's how we do question 28. Let's move on to question 29. All right, what does question 29 say? It says expand the logarithm. I've got log of 10 to the 5th times 3 to the 6th. Okay, cool. So in order to do a question like this, we've got to go back and look at our log rules, okay? And our log rules say that we can change multiplication into addition of two logarithms. So when we say expand, generally we're saying go from one logarithm to two logarithms. And that's exactly what I'm doing. I've got one logarithm, I'm going to break it into two. So our logarithm rules, go back to your notes and look at what your logarithm rules are. If you've lost them, you can Google logarithm rules and it'll come up. And so your rule says that you can rewrite the multiplication of a single logarithm as the addition of two logarithms. All right, cool. So I've rewritten my single logarithm as two logarithms using addition. And then my final step here is we taught y'all a rule about how we can rewrite the exponents for logarithms. And we can rewrite those exponents by bringing them in front, making them the coefficient of our logarithm. All right, cool. There's our final answer. This felt like it came out of nowhere. Go back, look at your logarithm rules. All right, question 30, something similar. It says expand the logarithm. And so again, I'm going from one logarithm to two logarithms. Expand, going from one to two logarithms. And in this case, I see that I've got division. I've got log base 6 of x over y to the 4th. And so another one of our rules says that if we have division in a single logarithm, we can rewrite it as two logarithms using subtraction. Let's go ahead and rewrite. Okay, so I've got log base 6 of x minus log base 6 of y to the 4th. I'm almost done. My last step is similar to question 29. I can use my exponent rule to rewrite that exponent of 4. All right, cool. There we go. So our final answer, log base 6 of x minus 4 log base 6 of y. All right, let's keep going with the logarithms. It says condense now. I've got to condense a logarithm. So as y'all might expect, condense means, hey, I want to go from 2 logarithms down to 1 logarithm. So let's go ahead and do it. So I'm essentially doing the exact opposite of what I did in the question right above. So I'm doing the opposite. We can rewrite the addition of 2 logarithms as the multiplication of a single logarithm. So let's do that. All right, and that's all there is to it. Log base 5 of 8 to the 20th times 7 to the 6th. And so 2 things happened. The first thing is I used my rule to say I can rewrite 2 logarithms as a single logarithm using multiplication. And the second thing that happened is I took my coefficients in front and I brought them up as exponents. Let me make that even more clear to y'all. And so that's how the 20 made it up into the exponent here, and the 6 made it up into the exponent here. Just the exact opposite of question 29, right above. Let's move on to 32. It says factor the following equation using the difference of squares method. All right, so switching gears a little bit, the difference of squares method, what does it say? Well, it says, given a function written in the form a squared minus b squared, this can be rewritten as a minus b times a plus b. Okay, so in plain English, what does that mean? Well, that means if I've got 2 terms and I can take the square root of both of them, I can rewrite it in a really simple way. So let's go ahead and do that. So let's go ahead and take the square root of 4x squared. The square root of 4x squared, that is simply 2x. The square root of 4 is 2, and the square root of x squared is x. And then I can take the square root of 9 as well. And so the square root of 9, as y'all already know, is 3. And so these are my a. This is my a, and this is my b term. So that's how we do the difference of squares. Now we can simply substitute our a and b values in here, and we are done. All right, we're left with 2x minus 3 times 2x plus 3. That's the difference of squares. Let's keep going. All right, question 33 asks us to simplify the square root of 12. It's no problem. So given the square root of 12, I can simplify that. That is the same thing as the square root of 4 times 3, right? 4 times 3 is 12, so those two are the same thing. And once I've rewritten it like this, because 4 is a perfect square, we can simplify here. So the square root of 4 is 2. And so my final answer is 2 root 3. You know you're done when what you have in the square root here there's nothing more you can do, right? And so in this case 3, there's nothing you can do with that. So we've hit a dead end. Let's keep going. Question 34 says, simplify the following. I'm actually going to cut it off right there. We'll make a new video here.